In 1988, a Cummins engineer named Roy Frick submitted a tolerance report that should have killed a casting run. The B-Series engine block being produced in the Columbus, Indiana plant had cylinder walls measuring 0.4 millimeters thicker than the engineering specification called for. That's less than the thickness of a credit card. His supervisor reviewed the numbers and told him to reject the batch. Roy Frick approved it instead. He signed off on castings that were technically out of spec, put them into the production line, and said nothing. He believed the thicker walls would hold up better under the kind of sustained heat and pressure a diesel block lives in every day of its working life. He was right in a way that nobody fully understood for another 15 years. That approved batch of out-of-spec castings became the foundation of what eventually evolved into the 5.9-liter Cummins B-Series diesel, the engine that Ram put in its 2500 and 3500 pickups starting in 1989. The engine that is still running today in trucks that have been through 400,000 miles, 500,000 miles, and in documented cases north of 800,000 miles without a rebuild. The most durable diesel engine ever installed in a pickup truck. And it started with a man who looked at a measurement that was wrong and decided the wrong measurement was better. Go ahead and hit subscribe. Leave me a comment at the end. I read every one. My name is Wade Tucker. I've been working on pickup trucks for 40 years. I rebuilt my first engine in 1986, a 6.9-liter International diesel out of a 1984 F-250. I have had Cummins B-Series engines apart on my shop floor more times than I can count. I have seen what's inside them. I have seen why they live so long. And what I'm going to tell you today is not marketing copy from Cummins. It is not a YouTube myth. It is the actual metallurgical and mechanical explanation for why this engine is different from everything else on the market, and why the accidental over-engineering of its block walls is only the beginning of the story. The block that should have been rejected. Let's talk about what Roy Frick's decision actually meant in engineering terms. A diesel engine block lives in a completely different world than a gasoline block. The compression ratios alone tell you that. A gasoline engine like the 5.4-liter Ford Triton runs at about 9.8 to 1 compression. The early Cummins 5.9-liter ran at 17.5 to 1 compression. The 12-valve version pushed it to 17.8 to 1. That means the force slamming down on the piston at the top of the compression stroke is roughly twice what any gasoline engine produces. And a diesel does that. Every cylinder, every firing cycle, under load at sustained RPM for the entire working life of the truck. Cylinder wall thickness is not just about containing pressure. It is about managing heat distribution. Thinner walls cool faster and unevenly. Thicker walls act as a heat sink. They absorb temperature spikes more gradually, distribute heat across a larger mass, and expand more uniformly as the engine warms up. The 0.4 millimeter overrun that Roy Frick approved gave the B-Series block walls that were slightly better at absorbing thermal shock than the spec called for. That sounds minor. Over the lifetime of a diesel engine, it is not minor at all. The cylinder bore on the early 5.9-liter Cummins measured 4.02 inches. The stroke was 4.72 inches. That is a long stroke design, which means the piston travels farther per revolution than a short stroke engine does. Long stroke engines produce more torque at lower RPM. They also put more side load on the cylinder walls. The piston rocks slightly in the bore as it changes direction at the bottom and top of the stroke. Thicker walls handle that side load more gracefully over time. They wear more slowly. The bore stays round longer. The engine maintains compression longer. The engine lasts longer. This is why 40-year-old diesel mechanics who have never heard Roy Frick's name will still tell you the same thing. The Cummins B-Series block is different. It feels different when you bore it. It machines differently than a Power Stroke block or a Duramax block. The metal is just there in ways that other blocks are not. The 12-valve, why simpler outlasted smarter. From 1989 to 1998, Ram trucks came with what is commonly called the 12-valve Cummins. That name refers to the number of valves, 2 per cylinder, 6 cylinders, 12 total. It is a mechanical fuel injection system. There is no electronic control module telling the fuel system what to do. The fuel delivery is governed entirely by a Bosch P7100 inline injection pump. Mechanical, no computer, no solenoids, no sensors that can fail. The P7100 pump is a masterpiece of precision mechanical engineering. It was designed by Bosch for commercial truck applications in Europe before Cummins adapted it for the B series. It has its own internal fuel lubricated bearings. It runs on the diesel fuel itself. It requires no third-party power to operate. If you have compression, timing, and fuel pressure, it fires. That is it. I have seen 12-valve trucks with the original P7100 pump still on the engine at 350,000 miles. Never touched, never rebuilt. Running within 1 or 2% of original delivery volume. That pump is not a weak link. It is part of why the 12-valve platform is considered by many serious diesel mechanics to be the purest mechanical diesel ever put in a pickup truck. The 12-valve also used a gear-driven camshaft. Not a chain, not a belt, a gear. The timing gear set on those engines is direct drive, steel on steel, with a lash specification that barely changes over the life of the engine. You can pull the timing cover on a 12-valve at 400,000 miles and find gear lash still within factory spec. That does not happen with timing chains. It does not happen with belts. Gears are the reason. If you want to understand why some Ram 2500 trucks from the mid-1990s are worth more money today than they were when they were new, this is the answer. A clean, low-mileage 1995 or 1996 Ram 2500 with the 12-valve Cummins and a manual transmission will sell today for $45,000 to $65,000 depending on condition. A truck that originally sold for around $24,000. That does not happen by accident. That is the market putting a number on mechanical immortality. From 1998, the 24-valve and the common rail. In 1998, Cummins introduced the 24-valve version of the 5.9-liter, 4 valves per cylinder instead of 2, electronic fuel injection replacing the mechanical P7100, the VP44 rotary injection pump initially, then the common rail system starting in 2003 with the third generation of the 5.9-liter. The 24-valve made more power. The 1998 and up 5.9-liter with the electronic system produced 235 horsepower and 460 pound-feet of torque in stock form, up from 215 horsepower and 440 pound-feet in the last 12-valve versions. By 2005, the Cummins 5.9-liter common rail was producing 325 horsepower and 610 pound-feet in a pickup truck. That is locomotive-grade torque delivered through a powertrain you could buy at your local Ram dealer. The common rail system operates at injection pressures of around 23,000 to 26,000 psi. That is what atomizes the fuel finely enough to achieve cleaner combustion at high power levels. The precision required to build injectors that operate reliably at that pressure, cycle after cycle for hundreds of thousands of cycles, is extraordinary. And Cummins, using that over-engineered block as its foundation, built an engine that could sustain those pressures without the kind of cracking, warping, or head failures that plagued competitors. The 2003 to 2007 5.9-liter common rail Cummins is the one I personally consider the peak of this engine's development. It has electronic fuel delivery with enough mechanical robustness to absorb abuse. It does not have the DEF system or the EGR complications that came later. It makes real power. And it sits in that same block with those slightly too thick walls that Roy Frick approved in 1988. The 6.7 that replaced it, and why the argument never ends. In 2007.5, Ram switched to the 6.7-liter Cummins. Larger bore, same stroke, same basic block architecture, but with emissions equipment added. EGR, exhaust gas recirculation, came first. DPF, diesel particulate filter, followed. In 2013, DEF, diesel exhaust fluid, and SCR, selective catalytic reduction, were added to meet EPA Tier 2 Ben 5 standards. The 6.7-liter is a capable engine. It makes more power than the 5.9-liter. A 2024 Ram 2500 with the 6.7-liter Cummins is rated at 420 horsepower and 1,075 pound-feet of torque. Those are numbers that would have seemed impossible for a pickup truck 20 years ago. The engine itself, the iron block, the forged steel crankshaft, the basic architecture is strong. But here's the argument that never ends in diesel circles. The 6.7 is encumbered with emissions equipment that adds complexity and failure points. The EGR system recirculates exhaust gases back into the intake. Over time, that deposits carbon in the intake manifold, the EGR cooler, and the EGR valve. The DPF traps soot and requires active regeneration cycles. The SCR system requires DEF fluid that crystallizes if the system is not maintained. None of these systems make the engine more durable. They are regulatory compliance systems layered onto an engine that was designed to run without them. The 5.9 liter didn't have any of that. It ran air and fuel. It burned the fuel, exhausted the gases, and did the work. The simplicity is not nostalgia. It is a genuine engineering advantage when the goal is longevity. And that is why you still see 5.9 liter Ram trucks being bought, maintained, and protected by people who understand what they have. What I have seen on my shop floor. I have pulled the head off a 1997 Ram 2500 with the 12 valve at 380,000 miles. Owner drove it from new. Same engine, same injection pump. Fluid changes only. Oil every 5,000 miles, fuel filter every 15,000. He brought it in because he was selling the truck and wanted to know what it was worth mechanically before he put it on the market. The cylinder walls showed wear. Of course they did. 380,000 miles of diesel combustion leaves marks, but the wear pattern was even, uniform around the bore. No oval wear from piston rock. No ridge at the top of the ring travel that would have told me the rings lost tension early. The crosshatch on the cylinder walls was still faintly visible in the middle section of the bore. That engine had not been bored. It had not been honed. It was the original factory finish, still partially intact at 380,000 miles. The head came off clean. No cracks, no erosion around the fire ring. The injector bores were tight. The pre-chambers, this was a 12 valve, so it used indirect injection with pre-combustion chambers, were seated correctly with no signs of movement. I put a straight edge across the head deck and checked flatness. Measured 0.003 inch deviation over the full length of the head. Factory spec is 0.006 inches maximum. That head was within spec at 380,000 miles on a diesel engine. That is not normal. That is the Cummins B series doing what it does. The cast iron construction manages heat in a way that aluminum simply cannot. Thermal expansion is lower. Warping under sustained high temperatures is lower. The geometry stays true because the material has the mass to resist distortion. This is why cast iron blocks kept being used in commercial diesel applications long after gasoline engines went to aluminum. The trade-off in weight is worth the gain in durability when the engine has to run forever. I have also opened a 2005 Ram 2500 common rail at 460,000 miles. Fleet truck, highway miles mostly. The owner kept meticulous records, every oil change, every filter, every fuel additive. The injectors were original, still delivering within specification. The high-pressure fuel pump had been replaced once, at about 280,000 miles, which is normal. The turbocharger was a rebuild, replaced at 315,000 miles because the variable geometry actuator failed, not the core. But the engine itself had never been opened. Never had the head off, never had the pan off. 460,000 miles, original engine, original block, original pistons. When I pulled that pan, the main bearing clearances were at the high end of spec. Not out of spec, at the high end. That is the difference between an engine with proper maintenance history and a neglected one. The crankshaft journals were smooth. The bearing material showed normal wear, distributed evenly. This engine had another 100,000 miles in it without a rebuild if the owner wanted to keep driving it. Why Ford and GM couldn't match it. The 6-liter Power Stroke that Ford ran from 2003 to 2007 is the most discussed engine failure in pickup truck history. Head bolt failure, EGR cooler failure, oil cooler clogging, coolant contamination. The block itself was not the primary problem. The block was International's 6-liter design, which was structurally sound. The failure points were in the cooling system design and the EGR system integration. Ford and International tried to build an emissions-compliant diesel, and the thermal management compromises destroyed reliability. The 6.4-liter Power Stroke from 2008 to 2010 had its own problems. EGR cooler cracking again. DPF regeneration issues. high fuel dilution of engine oil during active regen. Owners who deleted the EGR and DPF found engines that ran reliably. The stock emissions-equipped version was not. Ford spent enormous money on warranty costs during those years. The Duramax platform, specifically the LB7 from 2001 to 2004, had injector failure issues. The injector body O-rings failed internally, causing fuel return into the crankcase. GM extended the warranty on LB7 injectors because of how widespread the problem was. The LLY from 2004 to 2006 had overheating problems under heavy towing. The LBZ from 2006 to 2007 is widely considered the best Duramax. It fixed the LLY cooling problems and used more robust injectors, but it is still an aluminum head on an iron block, which creates thermal expansion differences that show up at high mileage. The Cummins B Series never had a catastrophic platform-wide failure. Individual components failed over time. The VP44 injection pump on 24-valve trucks had known failures. The lift pump could leave the engine vulnerable. The thermostat housing cracked on some years. These are component failures. They are not architectural failures. The engine itself, the block, the head, the bottom end, is not what breaks. That difference comes back to Roy Frick's decision in 1988. Thicker walls, more margin, more margin. An engine that was built beyond the minimum specification required to function, and deep into the zone where the margin becomes longevity. How to make a Cummins last forever. If you own a Ram 2500 or 3500 with a Cummins diesel, here's what matters based on 40 years of doing this work. Oil quality and interval are the first thing. Run a quality 15W40 diesel engine oil. I've used Shell Rotella T4 conventional for years in older pre-emission 5.9 engines, and it works. For common rail engines from 2003 forward, a full synthetic like Rotella T6 or Mobil Delvac 1 is worth the extra cost. Change it every 5,000 miles if you do a lot of short trips or idling. Highway miles, 7,000 is fine. The oil filter matters too. Use a Fleet Guard or Donaldson filter, not the cheapest thing on the shelf. Those brands built filters for Cummins commercial applications. They work. Fuel filtration is critical on a common rail engine. The high-pressure pump and injectors on a 2003 to 2007 5.9-liter common rail operate at tolerances measured in microns. Contaminated fuel kills them. Change the primary fuel filter every 15,000 miles. Change the secondary filter at the same interval. If you're fueling at independent truck stops where fuel quality is variable, consider adding a bypass filtration system. AirDog and FASS are the two brands most diesel mechanics actually use. They separate water, filter to 2 microns, and provide consistent lift pump pressure to the high pressure side. Coolant condition matters more on a diesel than on any gasoline engine. The cavitation erosion protection in diesel coolant, the SCA additives, the supplemental coolant additives, erodes over time. Test your coolant with a test strip every 30,000 miles. If the SCA level is low, add it. If the coolant is old and acidic, flush and refill. A Cummins diesel engine that runs with degraded coolant will develop cylinder liner pitting from cavitation. That is internal corrosion. It is preventable. It is devastating if you ignore it. Turbocharger oil. The turbocharger on the 5.9-liter and 6.7-liter Cummins is oil-cooled and oil-lubricated. When you shut off the engine, oil circulation stops, but the turbo continues to spin, cooling off on heat soaked from the exhaust side. If you shut down immediately after hard use without a cool-down period, the oil in the turbo bearing journal bakes. Over thousands of shutdowns, that baked oil deposits carbon in the bearing. The bearing starts to wear. Eventually, the shaft wobbles. The compressor wheel touches the housing, and your turbo needs replacement. 2 minutes of idle before shutdown after highway driving or towing. That is all it takes. 2 minutes prevents a $1,200 repair. The lift pump on common rail trucks. The factory lift pump on the 2003 to 2007 5.9-liter is the Achilles heel of that platform. It lives inside the fuel tank like a gasoline fuel pump, and it can fail without warning. If it fails completely, the truck shuts down. If it starts to degrade and deliver inconsistent pressure to the high-pressure pump, It accelerates wear on the CP3 injection pump. Replacing the factory lift pump with an AirDog 24G or a fast titanium series at around 150,000 miles is cheap insurance. You're protecting a CP3 pump that costs $1,200 to $1,500 to replace. Finally, do not let a Cummins diesel sit for extended periods with old fuel in the system. Diesel fuel degrades. The light ends evaporate. The fuel becomes waxy. In common rail systems, degraded fuel runs through injectors operating at 20,000+ psi, and it leaves deposits that change spray pattern. If the truck is going to sit for more than 90 days, add a fuel stabilizer and cycle fresh fuel through the system before long-term storage. Do those things. Keep records of every service. The Cummins diesel will outlast the truck around it. The frame will rust before the engine dies. The transmission will need attention before the engine does. The interior will wear out twice before you ever touch the bottom end. That is not an exaggeration. That is the documented experience of Ram diesel owners who have done the maintenance. The math on resale value. Here's a number that tells the story better than anything else I can say. In 2024, a clean, low-mileage 2006 Ram 2500 quad cab 4x4 with the 5.9-liter Cummins and a 6-speed manual transmission will sell for between $35,000 and $55,000, depending on condition and documented service history. That truck originally sold for around $33,000 to $36,000 new, 18 years old, 60 to 150,000 miles, and it is selling at or above original MSRP, in some cases significantly above, because there are not many clean ones left. The ones that existed have been bought by people who refuse to let them go. Compare that to a 2006 F-250 with the 6-liter Power Stroke. Clean example, well-maintained, low miles. $15,000 to $25,000. Sometimes less depending on what repairs have been done and what hasn't. The 6.0 Power Stroke reputation follows those trucks through every transaction. Buyers know what they're looking at and they price the risk accordingly. The market is not sentimental. The market is telling you what 40 years of diesel mechanics have learned the hard way. The Cummins B-Series is different. It was built different from the beginning, partly by design and partly by a decision that should have sent a batch of castings to the scrap pile. Roy Frick approved those walls, and the trucks that came out of that decision are still running today, decades later, in service that would have killed any other diesel engine on the market. That is the story, not a marketing campaign. Not a myth that mechanics repeat because they always have. An actual engineering outcome, rooted in a measurement that was 0.4 of a millimeter wrong, signed off by a man who trusted his instincts over his spec sheet. The engine worked, and then it kept working, and then it kept working some more, until the word indestructible stopped being an exaggeration and started being a documented fact. If you've got a Cummins diesel in your driveway, take care of it. If you're looking for a pickup truck that will genuinely last the rest of your life, find a clean 5.9 and maintain it right. And if you learned something today, drop a comment below. Tell me what year truck you're running and how many miles are on it. I want to know. I read every single one.